Hello guys, welcome you all for this end-to-end session on AIML, where you guys gonna learn everything that you guys needed to become in order to become a successful data scientist. For the past two, three, I think four more sessions, we are just having a theoretical and coding concept. Now you guys know what is the black box of it and how it is working together with the theory and coding knowledge. Guys, before this coming to the session, only one request from my side, like our side, I will say. Okay, just watch all the previous session videos so that you can have a better understanding of what we are saying. So if you guys are come to this stage, watching all the videos, great guys. You guys are great. Okay, you are like as sir always mentioning, right? You will be like top 1% of people who are just knowing the like black box of the algorithm and then the coding part. Okay, so yeah, today we're gonna work on logistic regression, the theory part, and then we're gonna see the coding. Okay, in the next session. Okay, so hope you guys are enjoying a lot. We are enjoying and we are learning a lot. Okay, so guys, I will just say keep learning, guys. Okay, that's a major. I will say that's a key for success. Okay, so without wasting any time, just we will jump into today's session. Today's session on all about logistic regression. It's a powerful tool for data science. Okay, I will show. Okay, guys, before going for this, for the past two algorithm which we have learned, right? One is linear regression, another one is multiple linear regression, right? Those are the regression algorithm. Okay, we know what is regression algorithm. From which branch it is? From machine learning, supervised learning, under which we are having regression. It is used to predict the continuous value. But this logistic regression is a classification problem. Okay, that's the only thing you need to look into. Logistic regression is a classification problem. Okay, so logistic regression is a powerful statistical method used for predicting the binary outcome, such as whether a customer will purchase a product or a loan applicant will default or it will rain or not. Okay, or it will be a holiday for tomorrow or not. Okay, like that, those are examples. Okay, it is very used for a binary examples. Okay, for classification it is useful. Okay, so yeah sir, over to you.
Yes. So, guys, logistic regression, we have used linear regression, multiple linear regression. Now, this is logistic regression. So, this is an algorithm model. Okay. A powerful tool for data science. Logistic regression is a powerful statistical model, okay, used for predicting binary outcomes. Okay. So, it is used for binary outcomes specifically and such as whether a customer will purchase product or a loan applicant will be default. So this is how it is specifically. See, each algorithm model has its specific purpose, okay, to solve specific problems. So logistic regression is used for this kind of like predicting. It works on predicting binary outcomes. That is the first speciality characteristics of it, and also it will whether the customer will purchase product or a loan applicant will default. So these are the characteristics of a logistic regression. So let's move to the other slide.
Yeah, sure sir. Yeah. So moving on, guys, we're gonna see. Okay, logistic regression assumptions. Okay, we have seen the assumption for linear regression, multiple linear regression. Similarly, we're gonna see the logistic regression again assumptions. First is linearity. So relationship between the independent variable and the log odds of the dependent variable should be linear. Okay, there is some change. Okay, there in multiple linear regression and linear regression, there should be a linear relationship between dependent and independent variable. But here there is a dependency. There should be a linear dependency between the independent variable and the log of the dependent variable. Okay, then independency, the observation should be independent of each other. This means the outcome of one observation should not influence the outcome of the another observation. This is major thing, guys. When we are having a problem like whether it rain or not, for raining there should be some set of features. If it is not rain, there should be some set of features. Both should not collide with each other. They should be independent of each other. No multicollinearity. If it is a linear or multilinear regression, it should be multicollinearity. But here there is no multicollinearity. That means the independent variables should not be highly correlated with each other. Okay, if we are having multiple independent variables, they should not correlate with each other. The thing is, it should be unique somewhere, so that only each and every independent variable will contribute much or will contribute properly to the target value, which we are going for a classification kind of problem. Okay, there should be no multicollinearity. Okay, no multicollinearity. Next, absence of outlier. This is a major thing, guys. Outliers can significantly impact the model performance and should be addressed. Okay, there should be no outlier. Since this is a classification problem, if you guys are having outliers, then there is a problem like misclassification will happen. Okay, it will be a class 0 and it will predict as a class 1. Okay, it is gonna say that that will not rain tomorrow, we will not bring umbrella, right? And we will go get a rain. So that kind of thing. Okay, so you guys need to understand this, because like there should be no outlier. Okay, the otherwise there will be a wrong prediction. Okay, so make sure guys you have these things in your mind, the assumptions like linearity, independency, no multicollinearity, and then absence of outlier. These are the assumptions that we need to have for this logistic regression. So yes, sir, over to you.
Okay, so logistic regression assumptions, let's understand what are the assumptions. One is linearity. So relationship between independent variables and the log odds of the dependent variables should be linear. See, guys, in linear and multiple linear regression, you will see the difference is that it is independent variable and dependent variable. Here, one thing else, like something else is added. Log odds of the dependent variable should be linear. This is the difference between logistic regression in when you understand assumptions in linearity. Okay, then independent variable observations should be dependent on each other. This means that the outcomes of one observation should not influence the outcome of another. So see, again the concept is same in logistic in linear and multiple linear and other regressions, because here the independent, it should be independent. Okay, it should not influence the outcome of another observation. So suppose if it was dependent, then it should have been dependent on other observations, right? So it is independent, not dependent. The observation is not influenced by the outcome of another observation. Okay, so no multicollinearity is that there is no the independent variables should be highly correlated with each other. Okay, no multicollinearity. So only the independent variables should be highly correlated with each other. So not multicollinearity. Okay, that is what it is. Only independent variables. Okay, absence of outliers. Outliers can be it will significantly impact the model's performance and should be addressed. So these are the assumptions which we need to clear when we are using logistic regression model. Okay, it's a powerful tool, so we can use it, but these assumptions we need to keep in our mind, and then we can go for application. Thanks. Let's move to the other slide.
Yeah, sure, sir. Yeah. Moving on. Let's see what we are having. Okay. Yeah. Logistic regression mathematical formula, models formula. Okay. We have seen the formula for linear regression, multiple linear regression. Okay. Hope you guys have remember that. Linear regression is simple. Y is equal to mx plus c. Whereas for multiple linear regression, it is very, very simple. Y is equal to m1 plus x1, m1 into x1 plus m2 into x2 plus m3 into x3 dot dot 2, m1 into xn. Okay. Plus c. That's it. Now, for logistic regression uses a sigmoid function. I will say blindly whenever you just hear the word of logistic regression, think of S curve. Logistic regression means S curve. That's it. That is called as a sigmoid function. To transform a linear combination of independent variables into a probability between 0 and 1, the likelihood of the outcome. Okay, finish. S curve. Logistic regression means S curve for used for classification. Let's see the formula. Y is equal to 1 by 1 plus e power, that is exponential power, exponential, minus b naught plus b1 x1 plus b2 x2 plus bn xn. Hope you guys now able to find something similar which we have learned before, right? Just see here. We are having something, right? Something fishy, we will say. B naught plus B1 x1 plus B2 x2 plus dot 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 B1 xn. What is this? It's a formula for multiple linear regression. 1 by multiple linear regression, 1 by e power minus multiple linear regression is a logistic regression. Okay, we have a new definition for logistic regression, which is 1 by 1 plus e power minus multiple linear regression is the logistic regression. So we will simply call this function, right, 1 by 1 plus e power minus x, where x we are having, right, that is multiple linear regression. That is b naught plus b1 x1 into b2 x2 dot 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 to bn xn. Guys, hope this formula is very easy. Don't try to memorize, guys. Just have an idea. We know linear regression, which is y is equal to mx plus c. We know logistic regression, sorry, multiple linear regression, that is y is equal to m1 x1 plus m2 x2 plus m3 x3 dot dot to m1 xn plus c. Now we know logistic regression. What is logistic regression? 1 by 1 plus e power minus multiple linear regression. What is multiple linear regression? We are having something called as b naught plus b1 x1 plus b2 x2 dot dot to bn xn. Some simple. Okay. Whenever logistic regression comes to your mind, it should be like a S curve and 1 by 1 plus e power minus multiple linear regression. That's it. Okay. I have put in a very simple way, guys. Never ever you guys gonna forget this. Okay. So yeah, sir, over to you.
Yeah. So well explained the formula, and guys, that is just feel it, just absorb it, huh? And then when you practice, you digest, and then you apply, then you'll learn. Okay. So never expect that in one go you are going to learn something. Okay. It takes good amount of time, patience, perseverance, long-term objective function of your career, and like contiguous approach towards knowledge, learning deeply and absorbing, digesting, and applying. Okay. So logistic regression model formula, it is logistic regression model uses a sigmoid function. That is what you need to understand. First idea, it uses sigmoid function to transform the linear combination of independent variables into a probability between 0 and 1. Why? See, in the definition, we understood that logistic regression, it is a model which uses binary functions. So, okay, log, that's why logistic. So it will use binary functions to predict 0 and 1, true and false kind of thing, 0 and 1, right? So it will represent whether customer will buy or will not buy or will default. So that was the definition, right? Okay, so it representing the likelihood of the outcome. Okay, it will suppose somebody has cancer or not, it will predict that. Okay, so this will be, that problem will be decoded into binary, like the outcome will be based on binary, true or false, 0 or 1, whatever. So the formula is y equal to y 1 divided by 1 plus exp minus b naught plus b1 into x1 plus b2 into x2 plus dot 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 x bn into xn, right? So this is the formula. This is simple math. So if you see, there are operators only. You can see operators. So operators like equal to, like the multiplication, equal to, minus, into. This is, it looks little complex, but it is nothing. Then if you dissect this formula, it is nothing more than dividing equal to plus minus into multiplying. Okay, um, that's it. There's no brackets, and that's it. It's nothing more than, if when you see these complex mathematics, just dissect it, just split it, and understand each bit, and understand the logic of that particular function, operator or operand. Understand the logic, you will get to know it is not a rocket science. It is just primary school mathematics, just combined and made it looks like complex. So whenever you see any complex formula, any complex math, just break it down to in pieces and understand those pieces, and then you get to know that what it is. Okay, so when you go and apply this, then you'll understand, then this is where you will understand black box functions happening. Input, function, and output. Okay, function is a black box, and that function happens within the formula. This is the model, guys. See, the entire logistic regression is this formula: plus, minus, divide by, uh, b2 into x2. You can put anything. I'll see, it is just a formula. It will calculate based on your definition, what you have given. It will go and formulate it the way, as per the characteristics of this model. Okay, so don't worry about anything. First understand the concept, then understand meta level, dissect that particular formula or any concept, understand deeply, and then we go for application. So this is what is actually logistic regression. So hope you have understood properly, because I made it very simple, guys, like primary school mathematics. I don't see more than that. It is y equal to 1 divided by, right, bracket 1 plus exp bracket minus bracket b naught plus b1. What is it? It is all operators. That's it. So hope you guys have understood how I explained it, because it's primary school mathematics. Just it is like we have simple sentences and compound sentences, right? So compound sentences make a paragraph. Same way, you have to understand. You have to simplify if you find any complex mathematics. Just understand the elements with which it is formed, with which it is built. So once you understand elements, this is called first principles, guys. When you find a big giant problem, split into pieces, understand pieces, solve pieces, you solve the big problem, and that's it. So when you see all these complex formulas, just split them into small logics and understand them, you understand properly end to end. Thanks. Let's move to the other section.
Yeah, sure, sir. So moving on, logistic regression evaluation metrics, guys. Hope you guys already know, right? So whenever we are creating a model, we need to evaluate a model. For that, we need some metrics. Okay. For regression, we are having metrics, right? Mean square error, MSE, and then we are having root mean square error, RMSE, and auto score. Okay. For class, that is for the regression problem. Since logistic regression is a classification problem, we have different metrics. That's it. Accuracy, it's a percentage of correctly classified uh, instances. Okay, that is what. Next matrix is precision, the percentage of correctly predicted positive instance out of all instance predicted as positive. Okay, recall, the percentage of correctly predicted positive instance out of all actual positive instance. Okay, guys, it will sound more similar, but like they are different. Okay, the precision and recall, hope like we have just discussed this 2 to 3 times in our session. Precision is it's a percentage of correctly predicted positive instance out of all instances predicted as positive. It relates on only positive, whereas this recall, it's a correctly predicted positive instance out of all actual positive instance. Here it is predicted as positive instance, it is actual all positive instances. Okay, it recall relies on entire data set. Precision relies on only positive data set, whereas this accuracy also take care of all the all the instances. Okay, hope you guys have understand this. For like finding the metrics or evaluating the classification model, because logistic regression is a classification model, we are having different formulas or metrics. We are having accuracy, precision, recall. There are different things, guys. Specificity, sensitivity, and then we are having something called as a F2 score. So these things are we are having. So very basic thing on accuracy, precision, and recall. Okay. Hope you guys have understand this. These are the way that how we can evaluate our classification model. Okay. Yes, sir. Over to you.
See, guys, if you understand the laws of uncertainty, when Heisenberg says that you can predict the position of the object, you can't predict the position of the object and the speed of the object at the same time. You have, as a human being, I'm saying, universe predicts that. But universe is built that way, but human beings have limitation. We can't be correctly predict precision and the position, the accuracy, which we call. But in machines, this is the major thing, guys. That is why these models are built. They will predict, they will see the accuracy, they will see the precision, they will do the recall. That is the human beings will not do be able to do. That is why we have built models, guys. That is the logic why we build machines and models. Okay, now, so accuracy is the percentage of correctly classified instances. Percentage of correctly classified instances. So whatever is classified correctly, that is accuracy. Okay. Precision is the percentage of correctly predicted positive, only positive instances out of all instances predicted as positive. Like you have a, you consider this three as a Venn diagram. Okay. So you have one side accuracy, the other side you have precision. In between you will have recall. So now I'll show you, you can visualize this. So accuracy is correctly predicted, classified, all the percentage of correctly classified instances, correctly predicted. You need to understand that. Precision is percentage of correctly predicted positive instances out of all instances predicted as positive. From positive, from positive, I'll say data set, which is predicted positive, you take percentage correctly predicted instances out of positive predicted positive instances. Okay, only from the positive, all the positive. Okay, now recall is the percentage of correctly predicted positive instance out of the all the actual positives. Okay, actual positive is the entire positive. Okay, and precision is only from the positive instance out of all instances predicted as positive. So, so there is a complete correlation if you see in these concepts. Accuracy, correctly classified instances, percentage, and then you have precision and recall. And recall is a balance of, I think, for it is balancing all because it is percentage of correctly predicted positive instance out of all actual positive instance. It is from the entire data of actual positive instances. And precision is out of all instances predicted as positive. Okay, there's a very thin line to understand these concepts, but when you practice, when you go watch all the sessions 5 to 10 times, you will get clarity. Just when you are listening, watching these videos, also write. So use different senses to absorb the information, because then you get clarity when you write the concept what you have understood. So there's a concept called Flyman technique. So whatever you have understood, try to write it and try to teach it to somebody or tell it to somebody who doesn't know, and suppose a kid or a person who is not literate, so you'll get to know whether you understood it properly or not. So there's a very thin line between these concepts, and that is where the magic happens, guys. In the very thin deep meta level understanding of these concepts, that is why theory is so super crucial, guys. Then application, I'll say, because when you don't know Chennai exists, you never know and you will never go. Application is separate. So once you know exactly which area, where is Pondicherry, where is Chennai, where is south, where is north, where is west, where is east, and what are the states, each and every, you know all the areas, then and only you can think of going or not going, right? But concept is like that. When you know, then and only you will be able to do it. Otherwise, it is a black box for you. You don't know what recall will do, what precision will do, what accuracy will do. So that is why knowing end to end deeply concept is very crucial for application. They both are brothers from the same mother. So you have to understand, you need to know both of them. You want to know the family, so you need to know both of them, like each and every element of it, so that you apply properly. Thanks. Let's move to the other section.
Yeah, sir, sure. So, guys, this is what all about today's session. We will pass here. So, we have just introduced you what is logistic regression. We have gone through what is logistic regression and what are the characteristics of it, what are the assumption we need to take, and then we have seen the evaluation metrics in order to evaluate this logistic regression. Hope you guys have understand this. If you guys have any doubts, just ping in the comments. We will take up here, and then we will just make sure your doubts are solved. So, hope you guys have enjoyed this session. So until the next session, meet you all in the next session, guys. Until then, keep learning, guys. This is what we can say. Just keep learning. If you guys feel any difficulty, please let us know using the comments. Okay, we will take up there and then we will just make your doubts solved. Okay. So until next session, guys. Bye. Take care. We will all meet in the next session, guys. Bye.
Yes, guys, watch all the sessions 5 to 10 times and write a feedback to us how we can improve and continuously improve these sessions. We'll be open to improve sessions. If you have any doubts, we'll be there to solve your doubts. Keep learning deeply with long-term objective function of your career and what you want to become. Write to us and let's have a conversation. Let's discuss and let's solve your problems related to AIML end to end. Keep learning deeply. Thanks.
Yeah, guys. Thank you.